Good morning, students. And today we are going to discuss about an experiment to measure the moment of inertia of any irregular body. And this is simple is an experiment called torsional pendulum. We are going to create a torsional oscillation on this pendulum. So first, torsional oscillation in the sense it is like due to twisting of wire. This to and fro oscillation of the disc is called torsional oscillation. And using this torsional oscillation, we can able to find the moment of inertia of any body, like regular or irregular bodies. We will create a small oscillation on this disc. And this is a torsional oscillation. We have to count the oscillation. First of all, what is the one oscillation? Suppose if you consider this end position is a reference point, when this goes to the maximum displacement and the same point when it is come back to the original position, the reference position, that will be the one oscillation. Right? Okay, first we will create the oscillation. And initially, first we will leave the first oscillation. So there may be some error in the back class issues. So first leave the first oscillation, and from the second oscillation, okay, next oscillation onwards we will start. Now I am going to consider this is a reference point. I start the clock from here. So when it goes to the maximum displacement, now the point has come over here, and it will be considered as one oscillation. So we have to wait to complete 10 oscillation. Now, this is the final oscillation. The cadence has come to the end now. This is the end of 10th oscillation. I stop the rotation, I can stop the stopwatch over here, and I got the time period of 10 oscillation. And it is now 1 minute 40 seconds. That means when you convert into seconds, it is nearly 100 seconds. Okay, so we will note it down on the table column. Without any object on the disc or without any object on the cadle, the time taken for 10 oscillation is 100 seconds. So now I note down what is the time taken for 10 oscillation, and I consider this is the trial one. Next is, again I have to create an oscillation. Just stop it first and create a small torque on the wire. Due to the torque, the disc will create an oscillation. That's a torsional oscillation. And that torsional oscillation we can create or we can find what is the time period of 10 oscillation. And just you can mention again that's a trial too. So just I am going to do it again. So I am going to start the clock from here. At the end of 10th oscillation, we will note down the time period. It's a 1. Stop it. At the end of 10th oscillation, I stop the clock and I found the time. It is 101 second. Here 101 second. At the end of 10 oscillation. This is the trial one. And this is the position without any masses on the cadle. Now I am going to fix one regular object, and this is a known mass of 635 gram. And we can able to find the diameter of this object. So this is a regular object. Just fix this regular object on the cadle at the center of the cadle. Now along with the cadle and the known mass, we can create again the 10 oscillation, and what will be the time period. So without the known mass, we found the time period of oscillation, 10 oscillation, and we can find it. That's a mean value as 100.5, and it is going to be considered as T now, which is the time taken for one oscillation without any mass on the disc. Now, after fixing the mass, the known mass on the center of the cattle. Again, we have to create a 10 oscillation. First, leave the first oscillation. So we have to create an oscillation, and from that, I have to measure what is the time taken for 10 oscillations. So I start the clock from here, and we have to count the oscillation. Now this is 1, 2, like that. And this is the last oscillation. Now at the end of 10th oscillation, I stop the watch. Now I got the time is 1 minute 43 seconds. That is, when we convert it to whole seconds, it is 103 seconds. So similarly, we have to do a second trial and note down what is the time taken for it. So this is everything is for with known mass, and that time period is going to be calculated as a T1. Then next is, along with the cattle, then known mass, I am going to fix an irregular body that which we are going to calculate the moment of inertia. Okay. Yeah. So this is our irregular body. Just I can take this log and consider this, and just keep this log at the center of the cattle. So now we have a cattle, the center mass and known mass, and there is an irregular body with unknown mass. And now we, along with that, create a torsional oscillation. This is the torsional oscillation. First, leave the first oscillation, and from this position, I am going to start the watch. So consider this, I started here. When it goes to the maximum displacement, and when it comes back to the same position, it's a one oscillation. Then 2. Like that we can count the oscillation. Now at the end of this 10th oscillation, I stopped the watch and I found the time taken for this 10 oscillation. In this position it will be 106 seconds. So again repeat it for the trial 2. So create again the oscillation. What is the time taken for 10 oscillations? We have to measure. First, leave the first oscillation. Okay. So there should be no shaking at all. The cattle has to be rotate uniformly. Okay. So now, first we will leave the first oscillation. And we are going to start the clock from here, and it goes to the maximum displacement, and it comes back here. So like that we can count it. Okay, so this is the final oscillation. Stop it. Now the time taken for this trial 2 will be 105 seconds. So just find the mean of these values. Hundred and 101 it becomes 105, and 103 it is the same 103. 106, 105, it becomes 105.5. This everything is time taken for 10 oscillation. But I have to find out the time taken for one oscillation, that is called time period. To find the time period, and this is 100. So how can you find the time period of one oscillation? 100 divided by 10. So this is 10.5. And next is, so the T0 value is 10.05. And this is with regular body, known mass, and that time period is considered as a T1. So this is 103 for time taken for 10 oscillation. So for one oscillation it is 10.3. Then this T2, along with the regular body and irregular body, the time taken for 10 oscillation of the candle is 105.5, and if you want to find the time period of one oscillation, it is 10.55. So these are all the time taken for the body with the different positions. First one is with the empty candle, and second one is with the known mass, and third one for with the unknown mass. Okay, so now we found T0, T1 and T2. And I already said the mass of the regular body is 635 gram. It becomes 0.635 kilogram. So to find the momentum of a regular body, that is I1 is equal to of m r square, where r is the diameter of the candle. Okay. Diameter of this regular body. So how can we find the diameter? Just take a vernier caliper. One second. So this is the regular body. To find the diameter of the regular body, we can use the vernier caliper. For the vernier caliper, there is no error and there is no correction. And a different diameter, we can fix this vernier caliper on the regular body to measure the diameter, and we found that MSR and VSC. So MSR is the first division of vernier, how much is completed over the main scale, that I note down is a 9.9. and for VSC, in this vernier scale we have a 10 divisions. Out of 10 division, which is exactly coincide with the main scale, that will be your VSC. So at different 5 position, I measured what is the MSR and VSC, and using this MSR and VSC, I can find the diameter of the regular body, and using the diameter, I found what is the radius of the regular body. So this is a general formula to find the I1 is equal to of m r square. So by substituting the values of m and r, I found the value of I1. Okay, so use this I1 on this formula. So I2 is equal to I1 7.864 into 10 to the power minus 4 and T2 square. So this is T2 square 10.55 square minus T0 10.05 square divided by T1 square 10.3 square minus 10.05 square. So by substituting all those values, we can able to find the moment of inertia of an irregular body like this log. For this log, I can able to find the moment of inertia. Okay, and before that, I have to measure the length of the wire, and the length can be measured. So for this irregular body, the log, we found that moment of inertia will be 0.0719 kilogram meter square. So by this way, we can able to measure the moment of inertia of any irregular body. Okay, thank you students.